Hello students. So today we are going to do a topic from moving charges and magnetism. Okay. So some numericals will do. This is from moving coil galvanometer, which is converted into an ammeter and a voltmeter. Okay. So this galvanometer can be converted into ammeter by connecting a resistance which is called shunt resistance. Okay. Which is connected in parallel. This is galvanometer, this is galvanometer's resistance. Okay, and this shunt resistance is connected in parallel with the galvanometer. Okay, and the value of this resistance is very small. Okay, and it is calculated by this formula, that is Ig is the current through the galvanometer, I is the main current, okay, through the circuit. G is the resistance of the galvanometer, okay, and this resistance is the resistance of this full circuit acts as a ammeter now, okay, and this is the resistance of the ammeter. Then we can convert galvanometer into voltmeter by connecting a resistance in series with the galvanometer, okay, and this value of this resistance is very large, and this circuit is now the voltmeter, and this resistance is given by this formula, that is V upon Ig minus G, and the resistance of the voltmeter is given by G plus R. Okay, let's do some examples. Okay, the question is a galvanometer of resistance 15 ohm gives full scale deflection for a current of 2 milliamp. Calculate shunt resistance needed to convert it into an ammeter of range 0 to 5 amp. So first you have to write what is given. Galvanometer of resistance. So this resistance is of galvanometer. So this is G. Gives full scale deflection for a current of 2 milliamp. So this is the current which is flowing through the galvanometer. So this is Ig. 2 milliamp. This you have to convert to ampere. So milli means you have to multiply by 10 raised to minus 3. Okay. Then calculate the shunt resistance, that is you have to calculate S needed to convert it into an ammeter of range. So ammeter, that is the range of the current which can flow, okay, is from 0 to 5. So you have to take I, that is current, as 5 ampere. Okay. So using the formula, that is of shunt resistance, S equal to Ig into G upon I minus Ig. Okay. Ig value is 2 into 10 raised to minus 3. G is 15. I is 5 minus Ig is 2 into 10 raised to minus 3. So here you cannot take this 5 minus 2 first. Okay. That is sometimes students write 5 minus 2 3 and then they write 3 into 10 raised to minus 3. This is not like that. This is proper subtraction. That is you have to subtract this value from 5. So this you have to write in terms of decimals. Now this is what 2 into 10 raised to minus 3. Correct? 2 into 10 raised to minus 3 means what? This is 2 upon 1000. So this value is 0.002. That is after point there are 3 numbers. Okay. So you have to write it here. So I'll write this 15 2s are 30. So 5 minus 0.002. And then you have to do the subtraction. That is 5.000 minus 0.002. 4 4.998. So if I remove the point, this will be 30 upon into 10 raised to minus 3. Okay, this you can cut. This will be 30 upon 4998. This you have to divide. So you have to multiply and see. If you take 6, you will get. Okay. And this is resistance. So here it will be ohm. Okay. Second question. A galvanometer has a resistance of 5 ohm and a full scale deflection is produced by 15 milliamp. Calculate what resistance must be used to enable the galvanometer to read 1.5 amp and 1.5 volt. Now here we have given both, that is this galvanometer is converted into ammeter and also it is converted into voltmeter. Okay, so whatever resistance we have to use to make it into ammeter and voltmeter, that we have to find. So first we have to write what is given. So galvanometer resistance is given, that is G 5 ohm, and the current which is flowing through the galvanometer is given, that is 15 milliamp. Milliamp means 15 into 10 raised to minus 3 ampere. Okay. Now you have to calculate what resistance must be used to enable the galvanometer to read 1.5 amp. So this is the current through the galvanometer when it is converted into ammeter. So I is given and voltage is given. Okay. So first we have to calculate shunt resistance. Ig into G upon I minus Ig. Okay, so again you have to convert this into decimals. So 15 into 10 raised to minus 3 means 15 upon 1000. Then you have to write it 0.3 numbers should come 015. 15 into 5, 75. Okay, so 1.500 minus 0.015. So this is 584, 1.485. So again you can remove the decimal and write it as 1485 into 10 raised to minus 3. Okay, now you have to divide this. 0, 0. This is around 5, so 0.05. This is resistance, so this is ohm. Okay, always write the units. Then you have to calculate for voltage. That resistance also you have to calculate. So R is equal to V upon Ig minus G. V is 1.5. Ig is 15 into 10 raised to minus 3. G is 5. Okay. So this will be 0.1, which is 1 upon 10 again. Okay. This is 1000 upon 10 minus 5. So 100 minus 5. 100 minus 5 is 95 ohm. Okay. So the question is, a galvanometer has a resistance of 100 ohm, a difference of potential of 50 millivolt between its terminals gives a full scale deflection. Okay. Calculate shunt resistance which will enable the instrument to read up to 5 ampere. So galvanometer resistance is given G 100 ohm, a difference of potential of 50 millivolt between its terminals gives a full scale deflection. So here we don't know the value of galvanometer current. Okay, we don't know this. But they have given that whenever there is a difference of potential 50 millivolt, it gives a full scale deflection. Means this is the voltage at which this current flows. Okay, so this becomes your VG, 50 millivolt. Millivolt means you have to convert it into volts, 10 raised to minus 3 volts. Okay. Now you have to calculate the shunt resistance, and which can read up to 5 ohm. So this is I. Okay. So to find Ig, you have to make use of Vg. Okay. G is the resistance. This is voltage. So you can make use of Ohm's law. So Ohm's law states that V is equal to IR. So we can write Vg equal to Ig into G. Okay. So Ig is Vg upon G. Vg is 50 into 10 raised to minus 3. And this is 100. Okay. Got this. Can write this as, can take this in the numerator. So this becomes 10 raised to minus 4 volt. Okay. Now use the formula S equal to Ig into G upon I minus Ig. Okay. Ig is 5 into 10 raised to minus 4. G is 100. I 5 minus Ig, 5 into 10 raised to minus 4. Again you convert it, 5 into 10 raised to minus 4. 5 upon 10,000. So this will be 0.0005. Okay. $4.995. So you can write this as, removing the decimal, you will get 4995. Okay, 95 10 raised to minus 4. You can cut this. This you can keep as it is, or you can take it. So it will be 500 4995.000. Okay, ones. So this is 0.01 S means resistance.